cell diagnostics worldwide. Well, to give a little context here, sickle cell conditions affect over 300 million people worldwide. About 300 million with the trait, maybe pass on to their kids. If they're having a kid with someone else's sickle cell trait, it will result in sickle cell disease. For the 8 million people who have sickle cell disease, this is where your cells, normally healthy and round, will fold over. What does this result to? These cells that are shaped differently will block blood flow, causing fatigue, pain, dizziness, shortness of breath, all these really challenging health conditions that affect people across their lifetime. Occupy 2.0, which can't really see the picture here, looks like fell off that slide, but we've got this little microscope. It's low cost, only $5,000 to $8,000, can be taken to remote outposts, whether that's in Senegal, whether that's in Nepal, and essentially it's an automated microscope that can help speed up the diagnostic process for sickle cell conditions. Now, of the testing that they've done, they've been able to speed up that process. That means you can have more people tested. You can get people who do have sickle cell into treatment faster. But this has just been done in small pilots, and we really need to expand it, as well as improve the technology so that it can reach more people. And at this point, I'll turn it over to Monica to talk a little bit about the solution that we've been working on.
So our solutions are mainly focused on improving the machine learning pipelines to detect sickle cell and normal cells. Doing this would help us it's very important to have an accurate model for sickle cell prediction. And what we have done is, we applied some of the deep learning solutions to our
Yeah, press down one more.
Down one more. Thank you.
Yeah.
Yeah, so our problem statement was to classify sickle cell and normal cell, and also automate it using deep learning, and also do the cell counting with the deep learning model. And the second task was to do image classification for a sickle cell disease type. So we used the existing data set and we leveraged that analysis to train our deep learning model, which actually was created using the labels, which we made an estimation based on the analysis which was published by the by these people. And also then we train a state-of-art de novo segmentation model, and we can get results we can get the given an image, we can get segmentation mask, and also we can get the cell type based on that. So if you go to next slide.
You have 1 minute left.
Thank you. So this is the final output. So we have predicted mass and the normal cells. So currently in the current system we do not have this cell level classification. So what we added is we added the cell level classification. Also, this is one shot algorithm. So it's not that we have to extract each cell and then extract the morphological features and then develop analysis to classify the cell type. So we use an already existing data set and we created our deep learning model which can automatically predict cell type and also can count the cell, the number of cells like normal cells or sickle cells.
Yeah, so now looking at the economics around this, this process is 4 to 5 times faster than the existing electrophoresis test, and applied to birth rates, early detection gives much better outcomes. There's a potential in Kenya to save 2,000 to 3,000 lives a year, and that equates to about 0.2% of Kenya's GDP. The cost for this has an ROI of 5 to 1 based on that GDP savings, and again for deployment costs. There is established insurance rates for covering the electrophoresis test, and these systems will pay for themselves within about 4 months and free 7,000 hours of clinic staff a year.
So our next steps is to build off. So there, we're going to pilot our Occupy 3.0 with partners on the ground in Nairobi, Kenya. After that, pending success, we'll scale across Africa and then start to address other bloodborne diseases, because as this demonstrates, there's a lot of diseases we gotta go tackle. Thank you for your time. We are Octopi 3.0.